Hello everyone, this is Dr. Garner here. I want to start off by introducing matter and its properties. So matter is any substance that has mass and occupies space, and we can divide matter into a couple of different categories depending on its properties. So we can classify matter as either being a homogeneous or a heterogeneous mixture, a compound, or as an element. All right, so we can start off by dividing matter based on whether it's homogeneous or heterogeneous. So heterogeneous matter is matter that's a mixture of multiple substances that are not mixed uniformly. So in other words, you can pick out pieces that are different from the other parts of the material. So they're heterogeneous, they're not mixed uniformly. In contrast to that, homogeneous matter is is material that's uniform throughout, that's uniformly mixed together. You can't identify one part that's different from the rest. So we can classify homogeneous materials as either being mixtures or pure substances. So homogeneous mixtures are mixtures of more than one substance that are mixed uniformly. And these are also known as solutions. We're going to examine solutions a little bit more thoroughly later in the course. So homogeneous matter that only contains one substance is just simply a pure substance. It's not a mixture. And we can further subdivide these pure substances based on whether they're compounds or elements. So compounds are substances that are made of more than one chemical element. So they're a combination of multiple chemical elements. In contrast to that, chemical elements are just one type of atom, one type of element, not a mixture of multiple types of elements. And we'll learn a bit more about what an element is during next week's lessons. Right, we can also think about the properties of matter. So materials' properties can be classified as either being physical properties or chemical properties. And I think it's probably a little bit easier to describe the chemical properties first. Chemical properties are describe how a material reacts. So it describes the chemical reactivity of a material. So how matter changes its structure and composition as part of a chemical reaction. So physical properties are essentially everything other than the chemical properties, so everything other than chemical reactivity. So physical properties describe the state of a material, the state of a substance. So these could be things like volume, size, temperature, melting points, boiling points, all of these other types of properties that are distinct from chemical reactivity. And I also want to take a moment here to introduce scientific measurements. So measurements always contain two parts, a number and a unit. The number tells you how much or how many of something you have, and the unit tells you what the scale of that measurement is, so how big that measurement is or how small that measurement is. And a little later in this unit, we'll take a look at different types of units that are used to describe measurements. All measured values inherently contain some error. It's impossible to precisely measure anything. So all measurements have some amount of error associated with them. And we use a system known as significant figures to keep track of how precise a measured value is. So what I want to do on the remainder of this slide is take a look at how we can figure out from a reported measured value how many significant figures are included in that measurement. In other words, how precise that measurement is. So there are a few different rules that we can use to figure out how many digits in a measurement are significant. So let's take a look at a few examples here. In this first example, we're given this measured value of 2,843.2. So all of the values here, all of the digits in this value are significant digits. So the first rule that I want to introduce here is that non-zero digits are significant digits. So here all five of these digits are non-zero, so they're all significant. So this value contains 5 significant figures. All right, let's take a look at another example. So here we have 2,843.20. This value has 6 significant digits. So of course, 5 of them are our non-zero digits. So all 5 of these non-zero digits are going to be sig figs. But we also have a 0 as well. So zeros that come both to the right of a sig fig and to the right of the decimal point are 0. So it has to be both. It has to be to the right of a non-zero value, or a non-zero digit, and it needs to be to the right of the decimal point. So here this 0 is both of these things. It's to the right of this non-zero digit here, this 2, and it's to the right of this decimal point. So that makes it a sig fig. So this value has 6 significant figures, the 5 non-zero digits, as well as the 0 that's to the right of a sig fig and to the right of the decimal. All right, let's look at another example. So 0.20. This value only has 2 significant figures, or 2 significant digits. So of course the 2 is significant since it's a non-zero digit. The 0 that comes to the right of the 2 is also significant because it comes to the right of a sig fig and it comes to the right of the decimal point. So that makes this second 0 here significant as well. The first 0, however, it does not come to the right of the decimal point, and it also does not come to the right of a sig fig, so it meets neither of the criterion that we need for a 0 to be significant. So the first 0 here is not a sig fig. So this value only has 2 sig figs. All right, in our next example, we have 10.20. All right, so of course our first 2 sig figs are going to be the 1 and the 2 since they're non-zero digits, so those are going to be significant. And then we also have a 0 that's to the right of the decimal and to the right of the 2. So it meets both of our criteria for being a sig fig that we saw earlier. It's to the right of a sig fig and it's to the right of the decimal. So that second 0 is also going to be significant. The first 0 that comes between the 1 and the 2, it's also going to be significant as well. So I'm going to introduce a new rule here as well, and that's that zeros that are between 2 significant figures are also significant figures. So all 4 of the digits in this value are sig figs. All right, let's look at another example. Here we have 1020. All right, so of course the 1 and the 2 are non-zero digits, so they're going to be significant. The 0 that comes between these 2 digits is also significant, since it's a 0 that comes between 2 sig figs. The 0 to the right, however, does not come to the right of the decimal, so it's not going to be significant. So it's to the right of a sig fig, but it's not to the right of the decimal, so it won't be significant. So this value only contains 3 significant figures. All right, let's look at one more example here. If I have 1020.0, things change a little bit. So our 1 and 2, of course, are still significant because they're non-zero digits. The 0 that comes between them is still significant because it's a 0 between 2 sig figs. Now by adding that extra 0.0 at the end of this value, we get a couple more sig figs out of this measurement. So the extra 0 at the end is going to be significant because it's to the right of a decimal point, and it's also to the right of a sig fig. The 2 was a sig fig. So that makes that last 0 significant. Since that last 0 is now significant, that means that the 0 that comes between the trailing 0 and the 2 is also significant. So the second 0 is significant because it comes between 2 sig figs. So 1020.0 contains 5 significant figures. All right, we can also apply this to values that are expressed using scientific notation. If we're analyzing how many sig figs are in a value that's expressed in scientific notation, you only want to look at the value that precedes the power of 10. So here we have 1 times 10 to the 6th. We're going to not consider this 10 to the 6th. We're not going to consider the sig figs there. We're only going to consider what comes before that. So here we just have 1 significant figure coming from that value of 1 that's a non-zero digit. We can look at a couple more examples here. If I had 1.0 times 10 to the 6th, that would have 2 significant figures. So the 1 is a non-zero digit, so that's significant. The 0 that comes after the decimal place and after the 1 is significant as well, since it meets both of those criteria. It's to the right of the decimal and to the right of a sig fig. All right, in the next example we have 10 times 10 to the 6th. Here we only have 1 significant figure. It's just the 1 here. Since it's a non-zero value, it's significant. The 0 that follows it is to the right of the 1, which is a sig fig, but it's not to the right of a decimal point, so it's no longer significant. It's not significant in this case. So we only have 1 sig fig in that value. If I have 10.0 times 10 to the 6th, that would contain 3 significant figures. So of course the 1 is significant. The trailing 0 after the decimal is significant because it's to the right of the 1, which was a sig fig, and it's to the right of the decimal, right? So it meets both of those criteria, so it's going to be significant. The first 0 is also significant now because it's between 2 sig figs. The 1 and the second 0 are significant, so that means that the first 0 must be as well. All right, so let's try out an example of one of these. So these practice problems, the way that these will work in the course is I would encourage you to pause the video for a moment and try to work through this problem on your own. Then once you've either figured it out or kind of gotten stuck, unpause the video and take a look at the solution that I'm going to show you. Working through these on your own and trying them out yourself is a really important part of learning and doing well in this course. So I strongly encourage you to pause and work through this video on your own this problem on your own before continuing with the video. All right, so we're being asked in this problem, which of these measured values contains the largest numbers of significant figures, or the largest number of significant figures? So we're just going to apply the rules that we just saw on that last slide. So let's look at these one at a time. If I look at choice A here, I see that this value has 5 non-zero digits. So remember, all non-zero digits are going to be significant. So that means that choice A, it's going to contain 5 significant digits. All 5 of those non-zero digits are significant, so we have 5 sig figs here. All right, in the next choice, we have 12.000. All right, so we've seen now that non-zero digits are significant, but these zeros here are also going to be significant because they're to the right of a sig fig, and they're to the right of the decimal point. So all of the zeros here meet those 2 criteria, so all 3 of these zeros will be significant. They all lie to the right of the 2 and to the right of the decimal point. So again, we end up with 5 significant figures in choice B. All right, now let's look at choice C. In choice C, we have our 5 non-zero digits, and then we have 3 zeros that follow them. These 3 zeros are to the right of sig figs, but they're not to the right of the decimal point, so they will not be significant figures. So choice C only contains 5 sig figs. So far all of our answer choices are tied. All right, in choice D, we need to look at our last rule here, and that's that zeros that are between 2 significant digits are also significant. All right, so if we break down what's going on in choice D, we know that the 1 is significant because it's non-zero. We know that these 3 trailing zeros past the decimal point are also significant because they're to the right of a sig fig, the 1, and they're to the right of the decimal point, so all 3 of those zeros are significant. The first 0 is to the right of a decimal point, but it's not to the right of the, it's to the right of a sig fig, but it's not to the right of the decimal point. But this value is still significant, this digit is still significant because it's between 2 other sig figs. It lies between the 1 and these significant zeros over here. So that first 0, it's going to be significant as well. So choice D contains 5 significant figures. In choice E, the 1 is significant because it's non-zero. Then we have these 5 zeros that come after the 1 and also after the decimal place. So all 5 of those zeros are significant as well. So that's going to give us 6 significant figures in choice E. So that's going to be our answer to this question. All right, we'll stop there for this video.